Welcome back, everyone. This is the Delta Workbook. It's Mr. Rostrea here, and this is Lesson 7. Today we're looking at Pythagoras' theorem in right-angled triangles. If you haven't done so already, pause the video and have a go at the do it now questions. Okay, first we're factorising the expression here, so we need to look at all parts of the expression and take out the highest common factor. I've got a 36 and an 18 here. They're both in the 18 times table. That is my highest common factor, so I take that outside my brackets. Now I need to work backwards. What do I multiply 18 by to get to 36? I multiply it by 2. So 18 multiplied by 2x will give me 36x. Next, I need to get from 18 to negative 18. Because the number is staying the same, we must be multiplying by 1, but it's going from positive 18 to negative 18. So we need to multiply that by negative 1. Okay, next, number 2. Here we're simplifying this expression. I can see that I've only got one term that begins with an x. So I'm going to write that at the start. That's not going to change at all. We have no other terms there that we're multiplying together. I now need to think about my y's. So we're multiplying all of these together. And when you just have y on its own, you need to think about that as y to the power of 1. Here, we are multiplying terms with the same base of y, so we need to add their powers together. So we've got 3, add 1, add 1. And that gives us 5. So it's going to be y to the power of 5. Next, we've got a question involving decimals and we're subtracting. So we start with the number we are subtracting from, and it's 3.098. Again, give yourself lots of space here. You don't want anything too squished up. And the first thing we do is put in our decimal points. They must stay in line when you're doing addition or subtraction. And now we're ready to put our second value in, 2.98. So it's 2 decimal point, then a 9, then an 8. You can leave this space blank or you can put a 0 there. It does not matter. We're now ready to start doing our subtraction. 8 take away 0, it's 8 still. 9 take away 8 is 1. 0 take away 9, we cannot do that, so we need to borrow 1 from 3. That will change to a 2, and we stick that on the 0. We've now got 10 take away 9. That leaves us with 1. Next, we've got our decimal point, and then we've got 2 take away 2, leaves us with nothing. So our final answer there is 0.118. Next, number 4, we're subtracting fractions. First thing we need to do whenever we're adding or subtracting fractions is find a common denominator. And the best way of doing that is by multiplying your denominators together. We've got 10 and 8, so if you multiply those together, we're going to get 80, and we're going to have our final answer out of 80 as well. Okay, how do I get from 10 to 80? I multiplied by 8, so I need to do the same with my numerator. And we're going to have 72 80ths. I'm taking away. Then how did I get from 8 to 80? I multiplied that by 10. Going to do the same with my numerator now, and we've got 30. I'm now ready to subtract my numerators. 72 take away 30, that leaves me with 42. It's not going to be our final answer though, because we can simplify. Okay, so we've got 42 over 80. They're both even numbers. That means we can divide them by 2. 42 divided by 2 leaves you with 21. 80 divided by 2 leaves you with 40. I cannot simplify that anymore, so 21/40ths is my final answer. Okay, finally, we've got the nth term. We've got decimal values here, but we still need to start by just writing that sequence out. Okay, 0.5, 0, 0.5. 1. So we've got negative values here and decimals, but we still need to work out what the common difference is first. What is happening in this sequence? Well, from negative 0.5 to 0, I'm going up 0.5. I'm adding 0.5 each time. So it's like we've got a form of the 0.5 times tables here. So I've actually found the first part of my nth term. It's going to be 0.5n. I now need to write down my 0.5 times table. Got 0.5. Then we've got 1, 1.5, and then we've got 2. How are we getting from the terms in our 0.5 times table to the actual terms in our sequence? Simplest one here, how do you get from 1 to 0? You subtract 1. Does that work from positive 0.5 to negative 0.5? Yes, it does. It works for all terms in our sequence here. So we've found the second part of our nth term, which is just subtract 1. So the nth term there, 0.5n subtract 1. Okay, let's have a look at our examples now. So today's lesson is all about Pythagoras' theorem. Pythagoras was not just a theorem, he was a very, very interesting person. He was alive around 2,500 years ago, so it was a very different world that he was living in. This is a person that was inspired to find out the way the world worked. He was interested in music, in art, in philosophy, and in mathematics as well. So if you don't know anything about Pythagoras, I'd strongly recommend giving the guy a Google. There are lots of documentaries out there, lots of great YouTube videos. This is just a very, very interesting person who achieved a lot throughout their lifetime. Regards to Pythagoras' theorem, this is a way of calculating lengths in triangles, because any right-angled triangle in particular will have a particular relationship between all of its sides. Now, the example that you've been given here in your workbook is h squared, this one here, is h squared is equal to a squared plus b squared. You might have heard Pythagoras' theorem slightly different. I'm going to write that down now. What you might have heard for Pythagoras' theorem is, write that in, okay? You might have heard a squared plus b squared is equal to c squared. So the only thing that's different here is we've written it the other way around, and instead of the c squared, they've used h squared. The reason why they've used h squared here is because h stands for the hypotenuse. And that will always be the side that's opposite the right angle. Okay, so you see our right angle is there, our hypotenuse is opposite it. And it will always be the longest side. So the hypotenuse of any triangle will always be opposite the right angle, if it's a right angle triangle. If it's a non-right angle triangle, it will just be the longest side. Now, the reason why I've written this formula down here, and I'm going to use this formula instead of the h, is that I think that letter h can sometimes confuse people. Because when you're given a shape and you're asked what h is, you would assume that that means the height of the shape. It does not mean that here. It means the hypotenuse, the longest side. So I'm just going to draw this triangle out again. Okay. It does not matter which way around your A and your B goes. You could have A here and B here, or you could have B here and A here. They are just the shorter sides. The important one is the hypotenuse, the longest side, which will always be C. Okay, so it's like we've got this squared plus this squared will equal this squared. Okay, A squared plus B squared is equal to C squared. And the first thing that you want to do with any right angle triangle question when you're asked to find the length of a side is to write out Pythagoras' theorem. So I would be writing out A squared plus B squared equals C squared. You're then ready to substitute in your values. Firstly, you want to identify what side are you trying to find. Here, we're trying to find this one, which was C, our longest side. I'm going to label this one as A and this one as B. So you now just need to substitute those in. Instead of A, you write 4, and it's 4 squared. Next, you've got your plus sign. Then instead of B, you write this value, which was 7. So we've got 7 squared. Then our equal sign, and that was equal to C squared. Okay, so I haven't done any working out there, I've just substituted in. Next, I need to simplify this. Because of big maths, we apply our indices first. We do 4 squared, 4 times 4, gives you 16. Still got our plus sign. Then we do 7 squared, 7 multiplied by 7. That gives you 49. And that's equal to C squared still. Haven't done anything with my C squared, that has stayed the same. Next, I need to simplify it a bit further. 16 plus 49, what do we get? Well, 49 plus 6, that gives me 55. Add the 10, that gives me 65. So we add these together, and we get 65 is equal to C squared. Now what I need to do is get from C squared to just C. How do you get from something squared to something without the square symbol, you need to do the inverse. What is the inverse of squaring? It's the square root. Okay, the square root. So what you need to do is type into your calculators square root 65. Once you've done that, root 65, your calculator might just say root 65 again. Just like with our fractions, if you want to find its numerical value, you'll press the SD button. So press the SD button. I'll make a note of that there. You press the SD button, and that will give you a long decimal number. Here it's 8.062 ... And you need to now pay attention to what the question has asked you to round it to. If it hasn't asked you to round it to anything, then you need to decide for yourself and label it. Here we've just done, well, in the example, they've done 2 decimal places. Let's have a look here. Yeah. So let's do 1 decimal place. In the example, you've got it up there already, 8.06. If they ask for 1 decimal place, then we look at the number after our first decimal place, which is 6, and that's going to round that 0 up to 1. So that'd be 8.1 to 1 decimal place. And your units now, all of our dimensions were in centimetres. So C will be in centimetres as well. So that was 8.1 centimetres to 1 decimal place. Okay, that's one way of doing it, and that's if you're trying to find the hypotenuse. In example 2, they don't want to find the hypotenuse now, they want to find one of the shorter sides, either A or B. It will be the same method whether you're trying to find A or whether you're trying to find B. So let's start again by labelling all of our sides. They've labelled A for us already, that's the one that we're trying to find here. I'll just make that a little larger. 7, that's going to be our B, and then the longest side opposite the hypotenuse, opposite the right angle, the hypotenuse will be C. Now I'm ready to start substituting in. So A was just A. That's the one we're trying to find. So that will stay the same. Next we need B, that was 7. So it's going to be 7 squared. And C this time was 11 squared. Okay, I now need to rearrange my equation. I'm trying to find A. So I want A equals something. What do I need to get rid of from this side of the equation? If I just want A, I need to get rid of that 7 squared. To do that, I'm going to subtract 7 squared from both sides. Okay, I'm just going to show you in a different colour what I've done there. I've subtracted 7 squared. And here I've subtracted 7 squared. Because when you're solving an equation, whatever you do to one side, you must do to the other. Those equations need to stay balanced. Okay, now we've got A squared equals 11 squared minus 7 squared. We can start simplifying that. So 11 squared is going to be 121. 7 squared is going to be 49. And then you can simplify further. We're now ready to do 121, subtract 49. What we're going to get there, we'll get 72. And now we're ready to square root again, because we need to get from A squared to A. How do we do that? We square root it. So we're going to need to do the same thing here to 72 and square root it. So I'll just write that out. That'll be square root 72. Just zoom down a little bit more so we've got a bit more space. Okay. So if you put that into your calculator, root 72, you'll get this long decimal number, 8.4852 ... Okay, in the question there, they asked you to round it to 2 decimal places. So let's do that. We need to look at the value after the second decimal place, which is a 5. 5 and above, we will give it a shove. So we give that 8 a shove up to a 9. Our units this time were meters. Okay, so you must be paying attention to those units there. So our final answer here is going to be 8.49 meters. Okay. If you take a look at my working out as well, you'll see that all of my equal signs here, all of them are in line. I've given myself lots of space in between the lines of my working out as well. And it's very easy for the person marking this to give me some working out marks because I've shown each step very clearly. Initially, I've shown I know what Pythagoras' theorem is. I've then shown I can substitute, that I can rearrange, and that I can solve an equation, round it, and include units. It's making it as easy as possible for the person marking your work to give you all the marks that you deserve there. So it's really important to keep your working out nice and structured, nice and clear. Okay then. So let's have a look at questions 1A to D. You'll notice that in all of these questions, we're trying to find the side that's opposite the right angle, the hypotenuse, the longest side. Okay, so in all of these, if we've got a squared plus b squared equals c squared, in questions 1A, B, C, and D, we're trying to find that c squared. Okay, let's have a go at the first one, number 1. Okay, so I can start off by writing out Pythagoras' theorem. A squared plus b squared equals c squared. Just going to zoom out, give myself a little bit more space. That should be fine. Now I'm ready to substitute in. A squared and b squared, it doesn't matter which way around you include these. Here I'm going to do 4 squared for A. Sorry, 4 is A, so it'll be 4 squared. And then for B, it's going to be 3. C, in this example, they've just used the letter X. Okay, that's still your hypotenuse, it's still the longest side that you're trying to find. We're now ready to simplify. So we've got 4 squared, 16. 3 squared is 9. And we haven't done anything with this x squared. It will remain the same. Next step, 16 plus 9. That gives you 25. To get from x squared to x, you need to square root it. Okay, so we're finding the square root of 25. Now, hopefully we don't need to use our calculators for this because we've recognized 25 is a square number. What number multiplied by itself, squared, gives us 25? That's going to be 5. So x is equal to 5. I now need to check my units. My units were all in centimetres, so they'll be in centimetres for my final answer. Okay, so 1A there, that was 5 centimetres. Okay. Now I just want you to pay attention to the working out as well here. I'm going to leave this Pythagoras' theorem at the top because that's what I'll be using throughout all of these questions. Okay. And we're now having a look at question 1B. Okay, so this is now question B. Okay, so we're still trying to find our hypotenuse, the longest side. I can now start by substituting in. Doesn't matter which way around you do these. I'm going to say that was A and that was B. So we've got 12 squared plus B, which was 5. So we've got 5 squared, and that's all going to be equal to C squared. Next, I simplify. 12 squared, 12 times 12, 144. 5 squared, we know from the last question, is 25. And that's all equal to C squared still. Next, I need to add them together. 144 add 25 will give me 169. I now want to try and find C. To get from C squared to C, you are square rooting. So I need to do the same thing here. I need to square root that 169. I now need to think backwards. What number multiplied by itself gives me 169? It's going to be 13. What were my units this time? My units were millimeters. Okay, my units were millimeters. So we've done that now. That was question B. And the answer here was 13 millimeters. Now, really, we didn't find C here. We found the letter Z. So I'll just change that. Here we've been finding the letter Z. Okay, then. Let's have a look at the next one, part C. Okay, we're now looking at question C. We're trying to find the longest side again, our hypotenuse. So trying to find C squared. This one, A, I'm going to use 24, B will be 18. So we've got 24 squared plus 18 squared. Okay, and that's equal to the longest side, C squared. In this question, they've used the letter Q, so we'll use the letter Q still. Okay, I now need to do 24 squared, 24 times 24, that gives me 576. And then 18 squared, 18 times 18, going to give you 324. That's all equal to Q squared still. Next, I need to add those two things together. We do that, we will get 900. I now need to get from Q squared to just Q, so I need to do the square root. What multiplied by itself gives me 100? Well, 3 times 3 gives me 9, and 30 times 30 will give me 900. Final thing I need to do is include my units. They were all measured in centimetres, so that will be my final answer, 30 centimetres. Okay, going to have a look at question D now. Okie doke. So this one, A is going to be 16 for me, B is going to be 30, and then we're trying to find C. This time it's labelled P, the longest side. So I'm going to substitute them in now. A, I'm saying is 16. And then I'm adding B, which was 30. And that's all equal to C squared. In this example, it is the letter P. So we'll just use that, P squared. Okay, I'm now ready to start simplifying. First, I need to do 16 times 16. This would be 256. Now, some of these questions you'll be allowed to use a calculator on. As you're going to see later on in the activity, for some of these we'll get a long decimal answer, and you would certainly be allowed to use a calculator there. For more simple questions, particularly 1A and 1B, where you have quite small numbers, you might be expected to do this without a calculator. So you're going to have to make sure you're up to date with your square numbers and you're able to recognize the square numbers from, say, 1 squared up to 13 squared at least. You need to know those square numbers. Okay, next it was 30 squared. We saw in the last example, that gives us 900. And that's all equal to P squared. Next, I need to add those together. So we've got 1156 equal to P squared. How do I get from P squared to P? I need to square root it. So I need to square root 1156 as well. This one you would not be expected to know, so you can use your calculators. If we find the square root of 1156, we will get 34. This time my dimensions were in meters. And so we've now found our final answer. Question 1, part D. That was 34 meters. Okay. Moving on now. Some of these triangles are differently oriented. Some of them are turned upside down. Some of them are laying on their side. So this is where it gets a bit trickier trying to spot what is your A, what's your B, and what's your C. The most important one there is our hypotenuse C, the longest side. So let's have a look at our triangle. I can see that my right angle is here, and opposite my right angle is always my longest side. So this one is going to be my C. It doesn't matter which way around the others go. I'm going to say 9, that'll be my A, and my H will be B. So if we just write it out, A squared plus B squared equals C squared. Right then, my A this time was 9. My B this time we don't know. So we're just going to call it the letter that they've used here, which was H. And then my C was 41. Now you can certainly get your calculators out now to do 41 squared. Hopefully you don't need them for 9 squared, that's going to be 81. So we've got 81 plus H squared, haven't done anything with that. I now need to do 41 squared. 41 times 41 will give you 1681. Just going to zoom out a little bit more now to give myself some more space to do this working out. Because what I need to do now is find H squared. That's all I want. I want h squared equal to a number. How did I get from 81 plus h squared to just h squared? I've subtracted 81. So I need to subtract 81 from this side as well to keep it balanced. So there we're going to get 1681 subtract 81. Okay, and now I can simplify that a bit more. So h squared, 1681 minus 81, that'll give us 1600. And then from h squared to h, you are square rooting. So you'll need to square root 1600 as well. Okay, what multiplied by itself will give you 1600? That's going to be 40. 4 times 4 gives you 16. Add your 2 zeros on at the end, and you get 1600. My units this time, sorry, this was question E that we're doing now. My units this time were centimetres. So h here was equal to 40 centimetres. So as you can see, again, we've got all of our equal signs lined up here, and you've left a nice amount of space in between your lines of working out. You do not want to do this too squished. You want to give yourself lots of space, make it clear for you to read, and as well whoever's trying to mark your work to read as well, so they can give you as many marks as possible. Right, next. We're now on question F. So we now have a look at F. Right, first thing I want to do is identify my hypotenuse, the longest side. It's going to be opposite the right angle. So in this example, my c squared is going to be 45. That's my hypotenuse. Okay. A and B, it doesn't matter which way around you label them. That will be my A, I will be my B. So A was 37. And B in this example is the letter I. So I've just used that, I squared. Okay, now I want to rearrange it because I'm trying to find out what I is. So I need I squared equal to everything else. How have I got from this line to this line? I've subtracted 37 squared. So I need to do the same to this side, my equal sign as well. Subtract 37 squared. Okay. We're then going to get 45 squared, subtract 37 squared. I can now simplify that and find out what 45 squared is. So I put that into my calculator, I'll get 2025. And we're taking away 37 squared, which was 1369. I can now simplify that even further and do the subtraction. 2025 subtract 1369 will give you 656. Remember that is equal to I squared. We're now ready to go from I squared to I by square rooting. So we get our calculators out. There's a square root of 656. Just a reminder there, we square rooted and square rooted. And here we're going to get 25.612. Now, in our questions, they haven't specified what to round it to. If they don't specify, then you need to decide for yourself and label it. In the examples, they've rounded to 2 decimal places, so we're going to stick to that for our main questions as well. We're now going to round to 2 decimal places. So, I'm going to have 25 points. First decimal place is a 6, second is a 1, so I need to look at the decimal place after that, which is a 2. 4 and below, we let it go, so that 1 will stay the same. Our dimensions were all given in millimetres, so our I will be in millimetres as well. So that was question F, and I is equal to 25.61 millimetres, and that's to 2 decimal places. Particularly if they haven't specified, you must show the person what you've rounded it to. Here we've rounded it to 2 decimal places. Okay, look at the next one. Okay, so this one's slightly different, only because we've got decimal points. You still need to approach it in the exact same method. Okay, so we are on G now. Just going to go up a bit. Okay, so question G. Again, with all of these, you start by showing the person that you know you need to use Pythagoras' theorem and just write it out. A squared plus B squared equals C squared. Next, we need to work out what side we are trying to find. We always start with the hypotenuse, the longest side that's opposite the right angle. So that is our C, 7.6. So let's write that in now. Next, we can go for A and B. Does not matter which way around these are. A will be my J. So I'll write that in, J squared. And then B was 6.1. So you've got 6.1 squared. Okay, next I need to rearrange it. I just want J. So to get from J squared plus 6.1 squared to just J squared, I need to subtract 6.1 squared from both sides. So you've got 7.6 squared, subtract 6.1 squared. Okay, I now need to simplify. I haven't done anything with the J squared, that will stay the same. 7.6 squared, that gave me 57. Oh. J squared was 57, not 77. Okay, just rub that out. So 7.6 squared gave us 57.76. And 6.1 squared was 37.21. Now I should mention here, when you have values like this with decimal numbers, sometimes you might get a very, very long number. So it's not necessary to write all of this out, okay, if you're working out. It is essential that you write in Pythagoras' theorem, you're substituting your values in, and you're rearranging. What you could do straight away is 7.6 squared minus 6.1 squared into your calculators. You could do that. You'd miss out that step, and what you'd get is 20.55. And that was equal to J squared. We now need to go from J squared to J, which means we all need to square roots. Square root J, keep it balanced, we need to square root 20.55. So you do that on your calculators. You get 4.533 dot. We're now going to round that to 2 decimal places. So that's going to go to 4.53, because 3 and below, we will let that 3 go. All of our dimensions this time were in meters. Okay, so J there was 4.53 meters. And again, for your essential steps in your working out, you would need to show what this is, J squared. You would need to show that the value continues on and that you've rounded it to 2 decimal places. So we need to label that 2 decimal places. Okay, ready for the final question now? Question H. So question H, they've rotated it. First thing you're going to want to do here is identify the hypotenuse, the longest side. Sometimes it's very difficult to spot what the longest side is, so you can use your right angle to help you. The hypotenuse is always the right angle. So that was our C. I'm going to call A, K, and this side will be B. So let's write our hypotenuse in first, our longest side, that was 21.7. A, I've said was K, A squared will be K squared, and B was 15.9. I'm going to leave my K alone, and I want to get rid of 15.9 squared. To do that, I need to subtract it from both sides. Just going to move along a bit so we've got some more space. So we've got 21.7 squared minus 15.9 squared. Okay, 21.7 squared, what would you get there? 21.7 squared gives you 470.89. And 15.9 squared will give you 252.81. Okay, I'm now ready to simplify that by subtracting. We subtract those, we'll be left with 218.08. Final thing I need to do now to get from k squared to k, we are square rooting. So you need to square root that as well. Square root of 218.08 will give you 14.767 dot. And we need to round that to 2 decimal places. So that's going to be 14.7, but this is going to round up now to a 7. Our units were in kilometers. This is a very large triangle, and we rounded that to 2 decimal places. Okay, so that was question H, and we've now completed lesson 7. If you want to practice further, then you can have a look at the Hegarty tasks up here. They're 497 to 499. The core bit activities as well are extremely useful for you guys to practice here, because if you go down to the apply section at the end of the textbook exercises, they have some real world applications of this. Anyone who's thinking about going into engineering, any sort of architecture, you're going to need to be able to perform these calculations and have an understanding of how these things work. Because if you're making structures with shapes like triangles, squares, rectangles, these are key skills that you're going to need some knowledge of if you're thinking about going into these careers. So it's a really, really useful one for you guys to practice that you're going to see in the real world. Hey, thanks again, and I'll see you next time.